Hello all, let's start section 7.3. 7.3 is estimating a population mean. The population mean, the symbol for the population mean is mu. We are estimating the population mean if or through the sample mean, correct? First we find x bar, which is the symbol for the sample mean. That will be our estimating point, and based on this we can estimate the population mean. First, what we need for this, or requirements, right? What we need, or you can write simple requirements. First, again, we need a random sample. All the time we need a random sample when we are dealing with these types of problems. Requirement number 2, population standard deviation. Population standard deviation, which is sigma, is known, it's given, is given or known, correct? 3, sample size. Our n should be greater than 30, or if it's not greater than 30, we should have these 2 words in the problem, correct? Population normally is normally distributed. If your sample size is less than 30, then definitely your population should be normally distributed. If your sample size is bigger than 30, you don't need, even if the population is not normally distributed, who cares, correct? We discussed before in chapter 6. Our point estimate, I'll put a star here, point estimate. Point estimate for mean is x bar, as I explained, correct? Your x bar is the point estimate for mu, is the point estimate for your mu, correct? The sample mean is the point estimate for the population mean. Now, as usual, first we have to find the margin of error. I'll create a formula for you. Margin of error. Remember, for the population, for the proportion, the margin of error, the formula was like this. E equals Z alpha over 2 square root of P hat Q hat over N, correct? Now, I'll do some math with this and I'll create a formula to find the margin of error when you are dealing with mean, correct? I can rewrite this formula as a E equals Z alpha over 2. If I do some algebra, I can rewrite this as a square root of P hat Q hat over square root of N. Basically, these 2 steps are the same, just the notation is different. Look at the top. Square root of P hat Q hat, it's actually giving me the standard deviation, correct? Then I can write E equals Z alpha over 2, correct? Sigma over square root of what? N. That will be your formula to calculate the margin of error for when you are trying to find the try to estimate the population mean. Maximum difference or confidence interval. How to build the confidence interval. It's the same idea. Before here you had p, now you put mu in the middle, correct? In the previous lecture it was p here. Point estimate for mu is x bar, then x bar plus e on the right side for the upper limit, x bar minus e for the lower limit. Correct? Or in some notations, they write this way. We use in the class this notation, but in some notations, it's x bar plus minus e. It's the same kind of meaning, correct? But we use usually this for the class. Now I'll give you steps when a problem for this giving you, which steps you should follow to solve the problem, correct? Steps. Step number 1, always check the requirement. Check the requirements, correct? Requirements means at the beginning of the lecture, I told you what we need. You have to check for that. In step 2, find critical value. Which means z alpha over 2 for the given confidence level. For the given confidence level. Correct? And step 3, find the margin of error. Find margin of error, which formula for that we just create. E equals z alpha over 2 sigma over square root of n. Use this one in step 3. Step number 4, confidence or build or make a confidence interval. Make confidence interval, which is, I was close to write p, now we are dealing with mu, which is mu less than x bar plus e greater than x bar minus e. That's it. That's the 4th step. If you follow these 4 steps, you can solve any problem, right? Now, an example. Oh, one more thing. At the end of the problem, I told you in chapter 6 that you have to write a short paragraph, translate your math to an English language, right? For these types of the problems, you can copy this. Even I gave you that one. I don't know what the exact population mean is. What the exact population mean is, but I'm sure, but I am this much sure. You can use your confidence level, for example, 95, 90, 99. Usually we use this 3, correct? For all of them percent. I am 90 or 95 or 99% sure it falls in my confidence and my confidence interval. You can copy this sentence or this paragraph at the end of each problem that you solve, correct? Now let's do an example. This example is about the resting heart rate. I think they did a study on some students. Random sample of 40 students. Random sample of 40 students. Or you can say in a random sample of 40 students. The average resting heart rate resting heart rate for the sample was 76.3 of course beat per minute. Correct? Assume the population standard deviation. Assume the population standard deviation is 12.5 beat per minute. Construct a 90% confidence interval. Correct? Let's see what is given. In step 1, we check the requirements. What the requirement is? Our sample is random. It's given. Requirement number 1 was random sample. It's there in the problem. You see random sample. You see this word. Requirement number 2 was size of the sample for the student. It's greater than 30. Also, you can make a note here that n is given to you actually. N is your sample size, 40. Correct? X bar is given to me, the average. Correct? When you see the average heart rate, that's your X bar. It's given as 76.3. Sigma is given 12.5. Correct? And I know my Z alpha over 2 because the confidence level is given 90%. Z alpha over 2 for 90, actually that's 99 in this problem, not 90, 99. For the 99% confidence interval, your Z alpha over 2 is 2.575. Correct? If it was 90, you can use that one. I give you all three. Correct? But for this problem, it's 99%. It's 2.575. Correct? Now, step 3, calculate margin of error. E equals Z alpha over 2, sigma over square root of n. Plug in the numbers, 2.575 times, or you can do this because it's all of them in the numerator. You can put all of them in the numerator, times your sigma, 12.5, over n, square root of n is square root of 40. And if you do this calculation, E equals 5.08. That will be your margin of error. Now I have the margin of error. I'll create my confidence interval. Mu less than x bar plus e and greater than x bar minus e. Then my mu will be less than x bar. My x bar is 76.3 plus e, margin of error 0.08, 5.08. On this side 76.3 minus 5.08. Correct? And if you can do the calculation, let's do the calculation. Mu equal, not equals, less than, let's use our calculator. I have 76.3, 76.3 plus 5.08, 5.08, which gives me 81.38. 81.38 on this side, and this side will be 73 point something, hopefully 76.3. What happened? Let's see.